Hi there! In this video, we are going to take a look at the process of determining the amount of elements in a confined space through sound analysis, or, to keep it shorter, the match counting problem. It is arguable that the general subject of audio analysis is at one of its peaks, from voice assistants like Amazon's Alexa and Apple's Siri to the progress with assistive technologies such as automatic captions and text-to-speech or speech-text transformations through deep learning. Much can be done with the enormous amount of information that we generate. The match counting problem is a challenge from the 2023 International Physics Tournament that caught our attention because of the possibility of extracting and manipulating data from audio through the question, how accurately can you determine the number of matches in a matchbox from the sound it makes when you shake it? Our initial approach was a blind test. Whether we could find a box with less or more matches was the query. With A, B, and C containing the arbitrary amount of 1, 3, and 21 matches, we shook the boxes without any specific method to find that C was easily spotted as the one with the highest amount. But interestingly, although not impossible, it was shown harder to differentiate between 1 and 3. Pondering about how it all looked from a closer point of view, we used the microphone from a video game headset and the Audacity software to record the A, B, and C sounds, also randomly adding the audio from a box with 9 and another with 40 matches. From the wave plot generated, spikes along them made us consider observing the intensity of the samples.
Through a Python script that we developed using the Barbosa library, spectrograms were generated. In them, the vertical lines represent the intensity over time in frequency intervals, and it's possible to verify that as we add matches, these lines get thinner, meaning that the intensity gets compressed and the sound, or the sounds as we will see, shorter. We believe that the best way to see those differences is by hearing them. Although it's not that easy to distinguish what is going on from just a quick listen, what you just heard was that concentration of intensity. Boxes with fewer matches generate more noise when shaken due to the space those matches have to change trajectory midair. But as the quantity increases, the space diminishes and so does the capacity to develop different trajectories, as if many matches act like only a big one. Knowing that sound waves are mechanical ones, we can use the kinetic energy formula to expand the explanation. In it, we know that velocity is amplitude times frequency, and assuming energy and frequency were the closest to constant, we denoted a relation between mass and amplitude. Additionally, we know that intensity is proportional to amplitude squared. So, as the mass increases, the amplitude decreases and the intensity gets compressed, giving the feeling of being lower. We admit that with a deeper analysis, using machine learning for example, samples could be grouped with a great accuracy into specific intervals, according to their mass, amplitude, and/or intensity. That's it. We would like to thank you for your attention and Professor Schoenmaker for his guidance and understanding during this whole project.